Good evening, friends. It's 7:26. I have activated YouTube link, so now we are available on Google Meet as well as YouTube Live both. So, as per your convenience, you can join at any place. But lecture will start at 7:30. That is in another 4 minutes. Okay. Thank you very much for joining in. Good evening, friends. I'm Santosh Takale. It's 7:30. So we'll start with today's session. Today's class will be taken by one of the new faculty, प्राजक्ता मैडम. मैं उनको थोड़ा सा इंट्रोड्यूस कर देता हूँ 1 मिनट में और फिर मैडम लेक्चर शुरू करेंगी. आज वो ऑसिलेशन पढ़ाएंगी आपको 12th फिजिक्स का. बिफोर proceeding, I will just introduce her. Prajakta madam had recently completed her masters in physics from IISER Mohali. ओके बहुत ही जल्द वो एस्ट्रोफिजिक्स में पीएचडी के लिए ज्वाइन करेंगी. उनका 11-12 जो है वो महाराष्ट्र स्टेट बोर्ड से ही हुआ है. तो जो बहुत सारे बच्चे महाराष्ट्र स्टेट बोर्ड के यहाँ पे मौजूद है और जो जीई मेंस के लिए या सीईटी के लिए क्वालिफाई करना चाहते हैं उन बच्चों के लिए एक इमीडिएट एग्जांपल है प्राजक्ता मैडम. 11-12 महाराष्ट्र स्टेट बोर्ड से किया है. उन्होंने जीई मेंस भी क्वालिफाई किया था जब उन्होंने 12th किया था और महाराष्ट्र स्टेट बोर्ड की जो MHTCET है उसमें उनका रैंक 114 म्हणजे 114 था. एंड बिकॉज ऑफ दैट पर्टिकुलर रैंक उनको COEP में CS यानी कंप्यूटर साइंस का कोर्स भी मिल रहा था इंजीनियरिंग के लिए. बट उन्होंने चुना आईसर, जो उन्होंने आईसर की एप्टीट्यूड टेस्ट से क्वालिफाई किया था. एंड देन शी डिड दैट. हर इंटरेस्ट जो उनका था वो परस्यू करते हुए फिजिक्स में उन्होंने मास्टर्स किया. तो आज आपको यंगेस्ट फैकल्टी मेंबर पढ़ाएंगे जो बहुत जरूरी है क्योंकि उनका जो प्रोसीजर जो जिसके थ्रू उन्होंने अपना एजुकेशनल करियर स्टार्ट किया और कंटिन्यू किया वो आपसे काफी मेल खाता है. हम लोग थोड़े बूढ़े हो गए हैं तो उस कॉन्टेक्स्ट में आपको प्राजक्ता मैडम के प्रेजेंस का फायदा होगा. पहला लेक्चर है एज यूजुअल. नो माइक नो वीडियो ये सब आपकी फैसिलिटीज नहीं दी गई है. बट एज सुन एज यू गेट मतलब जो रेगुलर बच्चे हैं उनको ये सब देने की कोशिश करेंगे. आज मैडम एक तरफा पढ़ाएंगी. कुछ इश्यूज होंगे तो बाकी मेंबर्स जिनको इस फैसिलिटी का ये दिया गया है एलिजिबिलिटी वो बच्चे मैडम को प्रॉम्प्ट करेंगे या मैं खुद प्रेजेंट रह के चैट बॉक्स में मैडम को प्रॉम्प्ट करूंगा. मैडम, we are done with introduction. Thank you very much for joining in. We welcome you. All the best for your first class at our end. Please proceed.
Yeah, thank you so much, Santosh sir. I hope I'm audible.
Yes,
I will
ma'am.
just go ahead and share my screen.
Yes, ma'am.
Yeah. Uh, so the topic I'm going to, or the class 12 topic that I'm going to teach today, or like start with teaching today, is oscillations. Um, so oscillations is basically very, I mean, it is also like a very normal day-to-day phenomena जो हम हर दिन oscillation के काफी सारे examples देखते हैं हमारे आजू बाजू में. तो for example, if you go to a park and you start playing on a swing, that is also an example of oscillation because वो जो swing है that is moving to and fro. It is going in the front direction and then it is coming to the middle position, the mean position, and then it is going backwards and then it is repeating this motion. So that is also a very common day-to-day example of the phenomenon of oscillations. So this is just introduction. The same thing they have also mentioned in the state board book in the introduction of this chapter. तो फॉर एग्जांपल ऑसिलेशन और ऑसिलेटरी मोशन के कुछ एग्जांपल्स उन्होंने देके शुरुआत की है कि जैसे हमने डिस्कस किया अभी कि स्विंगिंग ऑफ अ स्विंग इन द पार्क और पेंडुलम ऑफ अ क्लॉक. सो तुम लोगों के कुछ लोगों के घर पे जो वॉल क्लॉक्स होते हैं जिनमें नीचे पेंडुलम लगा होता है विच कीप्स मूविंग कॉन्स्टेंटली. So in such clocks, if you see the motion of that blob of the pendulum, it is also an oscillatory motion. Like the pendulum keeps swinging from back and forth. It comes to its mean position and then again towards the left and mean position towards the right. So it is a repetitive to and fro motion, which is also another example of oscillatory motion. The next example, some of you might play some instruments, some musical instruments, for example गिटार या फिर वायलिन, सितार, वीणा, ये सारे जो स्ट्रिंग इंस्ट्रूमेंट्स है जिनमें साउंड प्रोड्यूस होता है बिकॉज स्ट्रिंग्स आर वाइब्रेटिंग on the strings that are in the instrument. So the vibrations of these strings in the musical instruments, that is also a day-to-day life example of oscillations. So anything basically which does a to and fro or up and down regular motion repetitive in a repetitive manner. So it doesn't have to like it shouldn't stop by doing one oscillation. It has to do the same motion again and again. So that kind of motion is basically oscillatory motion. um, and then there is another kind of motion they have described here, which is the periodic motion. So what is periodic motion? It is again a repetitive motion, a motion which is repeated after a certain interval of time. So there has to be a specific interval of time जिसके बाद ये सेम मोशन रिपीट हो रहा है. कि जैसे फॉर एग्जांपल पेंडुलम का अगर एक्सप्लिसिटली एग्जांपल लेना चाहेंगे हम, तो दिस इज अ ब्लॉब ऑफ पेंडुलम and it is performing the same motion again and again at a specific time interval. So that is an example of oscillatory motion as well as a periodic motion. Because again, what we are seeing here is that um, yes, sorry. So what we see here is that the oscillatory motion is an example of periodic motion. So all kinds of oscillatory motions, because by definition they are repetitive motions, they are an example of periodic motion. Whereas the ulta thing of this statement is not true. Not all periodic motions are oscillatory motion, and we will also see an example of a periodic motion that is not an oscillatory motion. We will see it as we go ahead. But for the moment, what you have to remember is oscillatory motion is an example, or like oscillatory motions are also periodic. They happen repetitively after at a regular interval of time. तो व्हाट वी विल लर्न इन दिस चैप्टर कि हम ये चैप्टर के एंड में क्या सीखेंगे, और एज वी गो थ्रू दिस चैप्टर व्हाट वी विल लर्न, दैट इज बेसिकली हाउ टू फाइंड द डिस्प्लेसमेंट, वेलोसिटी एंड द एक्सेलरेशन for this oscillatory motion. So for any kind of oscillatory or more generally any kind of periodic motion essentially. So we will take some examples, जैसे कि simple harmonic motion for example, we will come to it. But through some of these kinds of examples, we will learn how to find displacement, velocity and acceleration of a body that is in a periodic motion. So now from previous classes that you have taken, you must know that in classical mechanics अगर हमें कोई भी किसी भी बॉडी का मोशन डिफाइन करना है कि फॉर एग्जांपल एक ब्लॉक वुडन ब्लॉक है जो ऐसे स्लैंटेड सरफेस पे सिचुएटेड है and we need to find out what is the motion of this block, what will it do after 10 seconds for example. So for these kinds of things, for these kinds of calculations, we need to know at least some of these things. We at least need to know displacement, velocity, acceleration. These are the fundamental things in trying to find out motion of any body. So we will basically at the end of this chapter we will learn how to find these things for a periodic motion. Now going to more specific thing, which is discussion of simple harmonic motion. So we will learn what is simple harmonic motion and everything in the upcoming time. But what we will essentially learn is specifically in simple harmonic motion, we will try to find out what is, for example, how this motion is graphically represented in terms of what is the plots of say displacement versus time, velocity versus time, these kinds of graphical representations, and what is the total energy of the system and how this energy is changing between potential energy, kinetic energy, total energy, these kinds of energy quantities of such systems. And then also what is damping of oscillation. These are the kinds of concepts that we will look at. They have also defined here the definition, formal definition of periodic motion, which is any motion which repeats itself in a definite interval of time. So, which we have already seen previously. And so it basically has to do a repetitive movement in a specific time. And now they talk about, as I mentioned earlier, there are all oscillatory motions are periodic, but not all periodic motions are oscillatory. So they have also given an example of a periodic motion that is not oscillatory, which is the uniform circular motion. So for example, take an example कि समझ लीजिए कि ये sun है and this is the earth that is going around. This is not a circular orbit, but just to take a simplified example, we will say that earth is going around the sun in a circular orbit. And so this motion is basically it is a periodic motion because as we know कि 365 days के बाद earth उसकी same position पे आ जाती है and then it does the same it follows the same trajectory over and over again at every 365 days ka interval. So this is a periodic motion, but is this an oscillatory motion? So this is periodic, but this is not an oscillatory motion. This is a uniform circular motion which does not follow which does not follow the definition of oscillatory motion, but it is definitely a periodic motion. So this is an example कि periodic है पर oscillatory नहीं है. So they have also given this example. And then coming to the simple harmonic motion. Simple harmonic motion के दो टाइप्स इसेंशियली कर सकते हैं हम. एक टाइप है लीनियर सिंपल हार्मोनिक मोशन एंड द सेकंड इज एंगुलर simple harmonic motion. So linear simple harmonic motion is basically if the path that the body is following, if that path is a straight line, then that motion is a linear simple harmonic motion. So for example, imagine कर सकते हैं हम कि there is some particle here, some block or anything basically, which is free to move in the x-axis. In the x-axis direction, it is free to move and it is doing this kind of motion in only one direction. And this path that it is following, it is a straight line. तो अगर जो बॉडी जिस पाथ पे टू एंड फ्रो मोशन कर रही है वो पाथ अगर स्ट्रेट लाइन है देन दैट मोशन इज कॉल्ड एज लीनियर SHM. Whereas if you consider an example of a pendulum, for example, तो pendulum कैसे move होगा कि it is pivoted at this point and only this string is allowed to move in this kind of a arc of a circle. So if you complete this is a entire circle, and what the motion that pendulum ka blob is following is essentially one arc of a entire circle. So this we can't call this motion as linear. So this is a angular SHM. So this is angular SHM ka example, pendulum for example, which is the same thing that they have also given here. Ki if the path of the path is the arc of a circle, then it is called as angular simple harmonic motion. Now you probably are already familiar with these concepts of period of a motion and a frequency of a motion. But just to revise, period is basically, if we take this circle ka example again, period is basically the time that it takes for this body to complete one entire circle and return to its original position. Or even if we take this example of linear oscillation, if the particle is moving, this is the mean position, and particle is oscillating like this. So the time that this particle takes to go from this point to this point and then come back here. So this is one period, right? I mean, that is the period. Oh, sorry. So that is the period of the particle, and period will denote by the letter T, and the frequency is basically inverse of period, which will give कि अगर हमने एक यूनिट टाइम में ये काउंट किया कि ये बॉडी कितने रोटेशंस कंप्लीट कर रही है, कितने ऑसिलेशंस कंप्लीट कर रही है, तो उतने अगर यूनिट टाइम में सपोज आई मीन एक यूनिट टाइम में 1 सेकेंड फॉर एग्जांपल में अगर वो n नंबर ऑफ रोटेशंस कंप्लीट करे, देन दैट इज द फ्रीक्वेंसी ऑफ दैट बॉडी, कि हाउ मेनी रोटेशंस पर सेकेंड it is completing essentially. So that is, this is time period and this is a frequency. तो टाइम पीरियड अगर हम बेसिकली टाइम पीरियड और फ्रीक्वेंसी का जो कन्वर्जन है, दैट इज टाइम पीरियड इज एसेंशियली इनवर्स ऑफ फ्रीक्वेंसी, if you're just counting in seconds. But usually frequency is given in terms of angular frequency also. We will also see this concept, we'll encounter this concept in the further part of this chapter, so I will just introduce it here. So angular frequency, which is denoted as omega, so that angular frequency is given as 2 pi into regular frequency, like normal linear frequency or like normal frequency. Normal frequency is just rotations per unit time, whereas the angular frequency is 2 pi into the n, the frequency, and then the time period will become 2 pi upon omega, because then omega is equal to 2 pi n, and we will come back to the same equation. तो टाइम पीरियड और एंगुलर फ्रीक्वेंसी के बीच में अगर रिलेशन जानना है हमें, तो इट इज दिस रिलेशन. ठीक है. नाउ we will start looking at the linear simple harmonic motion. So what they have basically done, I mean what we are going to also do is we will take an example of a block which is connected to a spring. So spring is anything elastic. So you can also take an example of rubber band, for example, which also has elastic properties. So imagine कर सकते हैं हम कि this block, so this is a frictionless surface and this is a wall, some rigid wall. और ये फ्रिक्शनलेस सरफेस पे हमने एक ब्लॉक को रख दिया है. लेट्स से उसका मास कुछ m है, एंड दिस ब्लॉक इज देन कनेक्टेड विद दिस spring, right? The spring is elastic, and the situation that we are going to consider is, let's say we pull this block to this point and then we leave it from here. We will pull this block like this and then we will leave it, let it go. Now, because the spring is elastic and it has restoring force properties, what the spring will try to do is it will essentially exert a force on this block, and that force will be in this direction, right? So the block will physically move in this direction. It will come to this. This is the mean position, right? This is the mean position of the block and also of the spring. So the block will cross the mean position. It will also compress the spring because of the energy stored in the spring. We will come to that, and then it will start this oscillatory motion. So this oscillatory motion is what we are going to study, and this is the linear SHM, right? So now, because of the elastic properties of the spring, the force that will be exerted on this block, we can say that force will be, the magnitude of that force will be proportional to the displacement. Now, what is displacement? Let's say this is the mean position. Usually, we define distances from the center of the origin, or center of the coordinate system. That is the origin of the coordinate system. But in these cases, while studying oscillatory systems, we will always consider displacements from the mean position of the object. So this is our mean position, and let's say this is the origin in some sense. So we will measure all distances from this point, not from the origin of the system from anywhere else. Now measuring displacement from this point, this is essentially some displacement x. So the displacement that the box or the block is going through, and also on the opposite side, the same thing will happen when the block is on this side. This is the displacement x again, right? Um, this is the same thing that I've also given here. So this is a positive x direction. So if your object is moving in this direction, that is a positive displacement. Whereas if your object is moving in the negative x direction, that is the negative negative displacement. Okay, so now this is the displacement that we're talking about, and what we are essentially saying is that we noticed from experiments that the force that is exerted on this block by the spring is directly proportional to the magnitude of displacement that is happening because of this oscillatory motion. And we also notice that if you observe here, when the block is at this point on the positive extreme, the force that is acting on the blocks, ये जो force है वो negative direction में act कर रहा है, because जो spring है वो box को इस side में pull करने की कोशिश करेगी. तो the force is acting in the opposite direction, whereas your displacement is in this direction. Similarly, अगर box का ये position है और box इस direction में जा रहा है, तो आपका डिस्प्लेसमेंट जो है वो इस डायरेक्शन में हो रहा है, पर अगेन जो स्प्रिंग है वो बॉक्स को जो मीन पोजीशन है उसका उसकी तरफ लाने की कोशिश करेगी. तो द फोर्स अगेन इज इन द ऑपोजिट डायरेक्शन. So we noticed two things from this ordeal. First thing is direction of displacement and force is always opposite of each other. अगर force इस direction अगर displacement इस direction में हो रहा है तो force आपका इस direction में लगेगा, and similarly अगर displacement इस direction में हो रहा है तो force आपका इस direction में लगेगा. And the second thing that we notice is that the force on the box is always in the direction of the mean position. So it is definitely opposite of displacement, but it is always in the direction of mean position of the box. So force direction is always towards mean position. ठीक है, so these are the two things that we have noticed, and this is the important observation कि हमेशा डिस्प्लेसमेंट के ऑपोजिट और मीन पोजीशन के टूवर्ड्स फोर्स लगेगा हमारा. एंड अगेन वी हैव दिस फर्स्ट थिंग विच इज की डिस्प्लेसमेंट जितनी ज्यादा है उतना ज्यादा फोर्स अप्लाई होगा. सो फॉर एग्जांपल टेक अ रेगुलर एग्जांपल कि आपने अगर रबर बैंड जो है यूजुअल रबर बैंड उसको जितना आप स्ट्रेच कर सकते हो उतनी ज्यादा मतलब अगर आपने कुछ होल्ड किया स्टोन वगैरह कुछ होल्ड किया वो रबर बैंड के दूसरे एंड पे और उसको जोर से खींचा, तो जितनी जोर से आप उसको खींचोगे उतना ज्यादा फोर्स लगेगा उस स्टोन पे व्हेन द स्टोन गेट्स थ्रोन आउट. तो दैट इज द सेम थिंग कि जितनी ज्यादा डिस्प्लेसमेंट होगी उतना ज्यादा फोर्स लगेगा. एंड बेस्ड ऑन दीज टू थिंग्स देयर कम्स अ नेगेटिव साइन हियर, बिकॉज हमने जैसे ये देखा कि डायरेक्शन ऑफ डिस्प्लेसमेंट और फोर्स इज ऑलवेज ऑपोजिट. तो एफ का रिलेशन हो जाएगा माइनस डिस्प्लेसमेंट के साथ माइनस साइन आ जाएगा बिकॉज ऑफ दिस डायरेक्शन थिंग. तो ये प्रोपोर्शनैलिटी कांस्टेंट बनने के लिए वी विल पुट अ के हियर. सो के इज बेसिकली कांस्टेंट ऑफ force constant. So this is given here कि the k is it depends on the elastic properties of the string कि string कितना ज़्यादा elastic है उतना ज़्यादा force लगेगा. But the name of the k is force constant, and this is the equation that we have written here, and this is probably the most fundamental equation in this chapter. तो ये equation अगर आपको याद है तो इससे आप आगे के सारे इक्वेशंस फाइंड आउट कर सकते हो डिस्प्लेसमेंट और वेलोसिटी और acceleration के. But this is the most important and most fundamental equation in this chapter. So you have to remember this कि f is equal to minus k essentially. Now we also know that f is equal to ma from Newtonian mechanics, right? तो अगर ये हमने इधर इंसर्ट किया कि ब्लॉक का मास हमारे एफ है एम है, एंड वी से कि एम ए इज इक्वल टू माइनस के एक्स, एंड इससे हम एक्सेलरेशन फाइंड कर सकते हैं ब्लॉक का कि कौन से मोमेंट पे क्या एक्सेलरेशन होगा, विच इम्प्लाइज कि ए इज इक्वल टू माइनस के बाई एम इंटू एक्स. So this gives the acceleration right away, right? So this is the formula for acceleration in these kinds of motion. And this is, I mean, the same expression here. uh, so another important thing is कि this equation f is equal to minus k, it gives the motion. With this equation, if you know the displacement, you can always predict, or if you know the force, you can always predict what the motion of the block is going to be. So that equation is also called as equation of motion, right? Which this term you might have encountered earlier also, but this is called as equation of motion. This is the important and fundamental basic equation for oscillations. Um, Now, and again, just to revise what is the significance of this equation? It basically says that the force acting on the block by the spring, the magnitude is directly proportional to the magnitude of displacement, and the direction of this force is always opposite to the direction of displacement. These two things is said by this equation. Now what, like, based on this equation, we can talk about what exactly happens in the motion of this block. So I will actually do it here. uh, तो अगर यहाँ पे फर्स्ट ऑफ ऑल लेट्स से कि हमने ब्लॉक को एक्सटेंड किया है एंड हमारे ब्लॉक की इनिशियल पोजीशन इज नाउ दिस. नाउ बिकॉज एफ इज इक्वल टू माइनस के एक्स. नाउ ये जो एफ है फोर्स ब्लॉक पे लगने वाला, वो जीरो बस एक ही कंडीशन में होगा, एंड दैट कंडीशन इज योर एक्स इज जीरो. एक्स इज जीरो मतलब ब्लॉक इज एट दिस पोजीशन, एट द इक्विलिब्रियम पोजीशन. तो बाकी सारे पोजीशंस पे ब्लॉक पे कुछ तो फोर्स एक्ट कर रहा है, राइट? Now this is the maximum. Let's say कि this block is in moving in this direction, so the x is positive, right? तो इस डायरेक्शन में मूव हो रहा है, x पॉजिटिव है, इसका मतलब है कि हमारा जो f है वो नेगेटिव होगा, तो ब्लॉक के ऊपर इस डायरेक्शन में फोर्स लग रहा है. नाउ अगेन कमिंग टू द इक्वेशन ऑफ एक्सेलरेशन, व्हाट दिस मीन्स इज कि बॉडी पे नेगेटिव डायरेक्शन में इसेंशियली इट सेज द सेम थिंग कि फोर्स जो लग रहा है वो इस डायरेक्शन में लग रहा है, एक्सेलरेशन जो लग रहा है वो इस डायरेक्शन में लग रहा है. तो बिकॉज देर इज अ नेगेटिव एक्सेलरेशन, उल्टे डायरेक्शन में एक्सेलरेशन लग रहा है इस ब्लॉक पे, विच मीन्स कि ब्लॉक इन दिस डायरेक्शन, इन द डायरेक्शन ऑफ डिस्प्लेसमेंट इज डिसेलरेटिंग. तो उसकी वेलोसिटी है जो धीरे धीरे कम होती जा रही है बिकॉज ऑफ दिस डिसेलरेशन इन दिस डायरेक्शन, इन द डायरेक्शन ऑफ डिस्प्लेसमेंट. तो एट वन पॉइंट इट विल कम रीच वन पोजिशन ऑफ वन एक्स पोजिशन कि जिधर जाके उसका वेलोसिटी एंटायरली जीरो हो जाएगी. At that position v will be 0 and x, let's say some value a hai, and this is the a is essentially the maximum displacement that the block can have, because उधर जाके उसकी velocity 0 हो गई, तो उसके आगे वो उस direction में नहीं जा सकता, उसको पीछे ही आना पड़ेगा. तो this is the maximum displacement that block can go through, and this maximum displacement is called as amplitude. एम्पलीट्यूड ऑफ दिस मोशन, राइट? नाउ इधर आके उसकी वेलोसिटी जीरो हो गई, बट उसके ऊपर स्टिल फोर्स लग रहा है बिकॉज डिस्प्लेसमेंट इज नॉट जीरो. फोर्स लग रहा है इन द ऑपोजिट डायरेक्शन. नाउ वेलोसिटी इन दिस डायरेक्शन इज जीरो एंड फोर्स इन दिस डायरेक्शन इज मैक्सिमम. तो व्हाट दिस ब्लॉक विल डू इज इट विल स्टॉप द मोशन इन दिस डायरेक्शन एंड इट विल स्टार्ट मूविंग इन दिस डायरेक्शन, राइट? नाउ मूव करते करते वो इस पोजीशन पे आ गया, लेट्स से. another point to also remember is because इस डायरेक्शन में जाते हुए उसके ऊपर एक्सेलरेशन लग रहा है, which means कि उसकी वेलोसिटी बढ़ते जा रही है because acceleration is in this direction and displacement is in this direction. तो उसकी वेलोसिटी is increasing. The moment it reaches this mean position of the block, that is the point where उसकी velocity is maximum. So there might be some questions in your exams, like competitive exams, which basically ask कि अगर ये ऐसी oscillatory motion हो रही है तो give me the maximum velocity that the block can have. तो you have to remember this thing कि block की maximum velocity होगी उसके mean position पे. When it passes through the mean position, that is when the block has the maximum velocity and also maximum kinetic energy, because half mv square is the kinetic energy, so it depends on velocity. Now either it has the maximum velocity, but at this point the force on the block is zero. So the block is at no force, but it has velocity, so it is moving in the same direction, it is moving in this direction. now that it started moving in this direction, let's say इधर कहीं पे तो है block हमारा, and then it is moving in this direction. धीरे धीरे the acceleration again starts increasing, the force comes into picture again, but now the force is acting in this side. The displacement is this side, but the force is this side. And at one point again the same thing will happen कि box उसकी maximum amplitude पे reach हो जाएगा, वहाँ पे velocity again zero हो जाएगी in this case. So this is the maximum amplitude on this side, and the velocity is again zero. The block halts again, and then again it starts to move in this direction. So this is essentially what is given in this paragraph. Also, you can read. Um, but this is how the motion of the block is happening, and all this we can tell using this one simple equation कि acceleration कहाँ पे है, force कहाँ पे है, और velocity पे क्या असर होगा. This is of course very qualitatively, so we are not quantifying all these forces and velocity. We are not giving the formulae, which we will now see in the next part. um, yeah. Now, and they've also given the definition, like the formal definition of linear acceleration, which is the linear periodic motion in which force or acceleration. So force is just um, is proportional to acceleration. So force or acceleration is always directed towards the mean position, which is what we saw, and the magnitude is always proportional to the displacement from the mean position, right? So this is the formal definition of, and it also gives the properties of linear acceleration. Um, Now coming to, sorry, yeah. Now coming to the finding velocity and the display, finding velocity and displacement. Yeah, and there are also these extra information blocks which I will not touch all of them. Matlab, there are some small questions or some activities that you can do, some calculations that they expect you to do, just to increase your conceptual knowledge. So these are extra points, and I will not touch up on them unless I think कि कुछ इसमें से कुछ पॉइंट है जो नेसेसरी है या फिर इंटरेस्टिंग है या फिर एग्जाम में पूछ सकते हैं. आई मीन इट इज अ वेरी स्टैंडर्ड क्वेश्चन काइंड ऑफ थिंग. अगर ऐसी कोई बात है तो आई विल टच अपॉन दीज squares, but otherwise you are always like welcome to read up about these, and if you have some questions you can direct them to me and I will be happy to answer. But I will not formally, because this is something you are expected to do on your own, to just increase your um, theory knowledge or practical knowledge through experiments and all these things. So I will not go through them unless I think they are like very relevant and important. Um, but not to say that they are not important. So you should definitely read them. Okay, now coming to the differential equation and solving these differential equations to get the values of like displacement and velocity. Um, yeah, so the first equation, the important equation that we saw is f is equal to minus kx, right? And then we also wrote this, which is where we start from. Yeah. Now we know that um, acceleration is just differential. I mean time derivative of velocity, and then velocity is just time derivative of displacement, right? So we will just plug this value here, and we will write sorry yeah second derivative of displacement, second time derivative of displacement is equal to minus k by m into x, and we will just rearrange these terms. So this is the differential equation that we will solve to get the value of displacement and also the value of velocity. We will see how, but this is the differential equation for linear recession. So anytime some question refers to anything related to differential equation of linear SHM, then this is the equation that we're talking about. Um, yeah. So this is the equation that we are talking about when we talk about differential equation of linear SHM.
Rajita madam, may
Huh.
I?
Yeah.
Yeah. Thing is that these kids, na, probably some are from 11th, some are from the 10th. So,
Hmm.
just for your understanding, sometimes they may have a problem with the differential equation itself. They must not have gone through the derivatives, because 11th covers derivative at last point of the maths 2. So,
Okay.
if you find it comfortable and you find it required, then you
Hmm.
can always explain them what is differential equation means, what is
Okay.
derivative means at that moment. What I
Huh.
find is you're going wonderfully well, and I am really appreciating your efforts and genuinely teaching skills. But
Hmm.
certain
Yeah,
things
yeah.
you are good, so you can always explain. Okay.
Yeah, sure, sure. Yes.
Sorry to this.
Yeah, no
Continue.
problem. Yeah. Okay. So, um, so different derivatives. So I said that acceleration is a time derivative of velocity, and velocity is a time derivative of displacement. So what is derivative? Essentially, derivative just gives you rate of change of something. So in this case, for example, if you go from point x1 to point x2 in time delta t, some delta t time, कि आपने फॉर एग्जांपल घर से शुरू किया जाना और आपके स्कूल तक पहुंचे इन हाफ एन आवर फॉर एग्जांपल, एंड सपोज कि घर से स्कूल का डिस्टेंस इज 2 kilometers, and you covered that distance in half an hour, right? So this is the rate of change of displacement. I mean, change of displacement is essentially going from one position to another position, and this quantity will give you at what rate your displacement has changed, or at what rate you have moved. And in common term, this basically gives you the value of velocity, कि what कि आप कितनी तेजी से चल रहे हैं, या फिर at what velocity you are walking, right? So this is just a delta displacement divided by delta time, कि what is the time, what is the distance that you have traveled in what amount of time. So that is a derivative of time with a derivative of displacement with respect to time, राइट? एंड देन एक्सेलरेशन इज अगेन द सेम थिंग, कि आपकी वेलोसिटी, कुछ कोई बॉडी की वेलोसिटी कितने टाइम में कितने अमाउंट से चेंज हुई. सो दैट इज डेल्टा वेलोसिटी, डिफरेंस इन initial velocity and final velocity, and that change has happened in how much time. So that is again the time derivative of velocity, and this is equal to acceleration, right? So that is derivatives. And differential equation is um, any equation that gives that has derivatives of quantities, and that gives some information about that system. कि जैसे हमने ये पहला equation दिया, it gives the equation of motion, कि how the motion of body will happen. Similarly, this equation is essentially the same thing. If you see, we have taken this equation and rearranged the same equation just to put it in a form where we are considering the derivatives of thing. We have gone from acceleration to the derivative of velocity, and from velocity to the derivative of displacement. And so this essentially gives the differential equation. So any equation which has derivatives, like terms of derivatives, is a differential equation. And what that will, I mean, why we have done this entire exercise is basically, uh, at the beginning of this chapter, we had said that we will try to find out acceleration, velocity, and Um, displacement, right? Now we found out the acceleration by saying a is equal to k upon m into x, right? Now we need to find out velocity and displacement. But instead of trying to find it in some other way, we know that acceleration is anyway is equal to dv by dt, right? Now, if we express this same equation, but just replace acceleration with the derivative of velocity, and then integrate this thing. So integration is opposite of derivation, right? So what we'll essentially say is velocity is integration a dt, like integration of acceleration with respect to time is velocity. So if we substitute acceleration, if we substitute dv by dt for acceleration in this equation and integrate that equation, that is what will essentially give us velocity. Similarly, if we substitute acceleration by d2x by dt, which is second derivative of displacement, and then integrate it twice, that is what will give us displacement ka formula. So we are using the same. equation and then just substituting it with derivatives of things that we want to find out. Like I hope this I mean helps a little bit. Okay, I will come to this example in a while. Uh, okay, or maybe I should just work out the example because I don't know if I will be able to finish this in today's class. Okay, okay, I'll just do one thing. I'll follow through the two examples. So I had prepared this one example and another example from exam, like actual competitive exam. So it doesn't seem like I'll get a time to finish the entire like solving of differential equations. So I will stop here in teaching now at this point, and we will talk about like two examples based on what we have learned. Um, and before I do that, just like a recap of all the formulae that we have learned today, so that you have the formula in front of your eyes, and you can also try to solve the equation using the formula side by side, like as we go. Um, so first equation, the important equation that we saw is F is equal to minus kx, and then we substitute F for ma, and what we get is acceleration is equal to minus k by m x, right? Uh, then we also saw the equation for um, time, time period, and that is equal to 2 pi upon omega, where omega is equal to 2 pi into regular frequency. I think this is these are pretty much, and then the differential equation we saw is d2 x by dt square plus k by m k by mx is equal to 0. Another one important thing that I forgot to mention, um, or like which I think I should mention here, is that we, if you see here, for example, we have defined k upon m as omega square. So the omega that we saw here, this same omega, and we are defining this factor of k by m. So this factor that comes in the acceleration ka formula. So we are taking this factor and we are defining it as omega square. So omega will essentially be equal to k upon m. I will just erase the, I mean, I'll just make this neat so that you can, if you're noting down, you can also note down these formulas. Yeah. So this is the first thing that we learned. Then the second formula. Then we also saw this relation, and this you already probably know. And then we are defining. This is a definition. I mean, it does not come. I mean, it has some physical relevance, but for now, you can say that we are just defining the k upon m factor to be equal to omega square, and then which essentially implies that omega is equal to root of k upon m. Okay, and this is the differential equation of the SH equation. So these are all things that we learned today. Based on this, we will solve this example 5.1. What they are essentially saying is a body of mass zero point 0.2 kg. So mass is equal to 0.2 kg. And this is an important, I mean, this is a practice that your school teachers also might have told you, but this is what I used to personally follow, is every time you read an example, either it is for the competitive exams or for board exams, keep an habit of writing down what all things are given and what thing you need to find out. It essentially helps to build a habit of just looking at the example and knowing the things that are given and what has to be found out, and it helps to find out the formulae that are relevant in solving the example. So keep this habit always. Um, so body of mass 0.2 mg performs a linear SHM. So all these equations that we saw, they apply here. It experiences a restoring force of zero point 0.2 Newton, restoring force of zero point 0.2 Newton when its displacement from the mean position is 4 centimeters. So at this point, the displacement is 4 centimeter. Also keep everything in SI units. Otherwise, there's a chance that you will mess up the units in the final answer. Based on this information, what they have asked is it experiences force of this thing when the displacement is 4 centimeter. Determine one force constant. So we have to first find force constant. Second is period of acceleration. So T we have to find. And the third quantity they have asked is acceleration of the body when its displacement from the mean position is 1 centimeter. So acceleration when x is equal to 1 centimeter. This is an important fact to notice, that acceleration of the body is not constant. I mean, it is there in the equation, but I'm just pointing it out verbally, that acceleration of a body in SHM is not constant at all points. So whenever a question asks you to find the acceleration, they must have given at what displacement, कि कहाँ पे निकालना है जो acceleration है. You can't just ask for acceleration of SHM. You have to ask acceleration of SHM at what point, at what displacement. Then only it makes sense. Just to explicitly say this. Now we will try to find all these things. So first is k. Now going back to this equation, f is equal to minus kx. We have been given f and we have been given x. So k is equal to f upon x. We are just finding the magnitude. So we are dropping the negative sign. What will this be is 0.2 upon 4 centimeter, which is 4 into 10 to the power minus 2 meter. And this will essentially be 20 upon 4 is equal to 5. And the unit of this thing is meter, Newton per meter, because going back here, this is Newton, this is some unit, and this is meter. So the k unit is units of Newton per meter. Okay, remember this. This is also important. I mean, there are some very easy questions in all these exams which just ask what is the unit of a quantity or what are the dimensions of a quantity. And they are very easy questions, but they're also very easy to mess up. So always keep an habit to track the units of things as you learn new formulae and new concepts. So this is the answer of first question कि k का value आ गया हमारे पास 5 न्यूटन पर मीटर. सेकेंड क्वेश्चन में दे हैव आस्क्ड कि टाइम पीरियड क्या है, राइट. तो टाइम पीरियड का हमने यहाँ पे फॉर्मूला निकाला 2 पाई अपॉन ओमेगा. So time period is 2 pi upon omega. Now we need to see in the question whether they have given omega. They have not given omega. So we need to find another formula कि जहाँ से हमें omega पता चल सकता है. So have they given this frequency? No, they have also not given the frequency. Now we are coming to this formula. तो इस formula में we need force constant का value जो हमने previous सब part में निकाला, calculate किया, और mass दिया हुआ है. तो mass दिया हुआ है क्या? हाँ, mass दिया हुआ है हमारे पास. तो we can use this formula to find the omega first. तो इसमें ओमेगा की वैल्यू आएगी रूट के अपॉन एम विच इज इक्वल टू रूट ऑफ, ये निकाला हमने 5 डिवाइडेड डिवाइडेड बाय मास की वैल्यू दी हुई है उन्होंने 2.2 kg. एंड वॉट एवर दिस वैल्यू कम्स आउट टू बी, दिस विल बी, yeah, sorry, and then we have to plug this thing in 2 pi upon 5 upon 0.2, राइट, कि ये ओमेगा का वैल्यू आया और ओमेगा का वैल्यू हमने यहाँ पे प्लग किया. सो टाइम पीरियड इज इक्वल टू दिस थिंग एंड इट इज इक्वल टू, मैंने उल्टा किया है बस बिकॉज दिस थिंग इज इजियर टू कैलकुलेट जस्ट बाय हेड एंड दैट वैल्यू विल बी, दिस विल बी 0.04. तो रूट आ जाएगा 0.2. सो टाइम पीरियड इज गोइंग टू बी 2 pi into 0.2 which is equal to 0.4 pi. This thing will be always in SI units because we have converted everything into SI units. So the answer will be 0.4 pi seconds. You can keep the value as it is or you can multiply with pi. That is just like, I mean, that is the next thing. And then third thing they're asking is this acceleration at x is equal to 1. तो एक्सेलरेशन का फॉर्मूला अगेन हमने यहाँ पे देखा है कि माइनस के अपॉन एम इंटू एक्स. तो के हमने 5 मीटर न्यूटन पर मीटर निकाला हुआ था. एम का वैल्यू उन्होंने दिया हुआ है 0.2. सॉरी, तो दिस इज 0.2। और डिस्प्लेसमेंट जो दिया हुआ है वो उन्होंने पूछा है कि एट 1 सेंटीमीटर, राइट? तो डिस्प्लेसमेंट आ जाएगा 1 सेंटीमीटर, विच इज 10⁻²2 मीटर. And now remember, we had dropped the sign or this minus sign when we were calculating the value of k, because k का value हम positive में लिखेंगे like always, because the direction of f is dependent on displacement, not on k. K is always positive. But when you are finding the acceleration can have negative value. So you have to not fall in this trap of like omitting this negative sign or just forgetting the negative sign. Otherwise, आपका आंसर गलत आ जाएगा. आप positive answer लिख दोगे and that will not be right. So you have to remember कि acceleration can have negative sign. So for such quantities, you have to make sure that you are keeping or retaining this negative sign. And then displacement can also have negative sign. So you have to take into account all these factors. कि अगर जैसे बोला होता क्वेश्चन में कि ब्लॉक जो है उसका डिस्प्लेसमेंट नेगेटिव साइड में एक सेंटीमीटर है, तो नेगेटिव साइड में अगर 1 सेंटीमीटर है तो यू हैव टू कंसिडर द डिस्प्लेसमेंट टू बी माइनस. दिस इज जस्ट टू क्लैरिफाई एंड डोंट फॉल इन दिस ट्रैप. दिस इज अ वेरी ऑब्वियस मिस्टेक. And then whatever this thing will come out, 0.5 into 10⁻²2 into 0.2. This is units is meter per second square. So this will be some, I think, 20.25 meter per second square. You can calculate this. One thing I noticed here is they have, I mean, just to check the answers, first answer is correct, 5 Newton per meter second, 5 Newton per meter. The second answer is 0.4 pi seconds. That is also correct. Here they have made this mistake of taking the displacement 4 centimeter, because in the earlier question they had said that it experiences restoring force of this restoring force when the displacement is 4 centimeter. So that is in the question, but so they have taken this point not 4 meter value from this part. But when they're asking about the acceleration, they have asked at 1 centimeter point. So this displacement in fact should be 1 centimeter if you want to find the acceleration at 1 centimeter. So you might get confused when trying to tally the answer that we found with this answer, but that is the point of discrepancy here, that they have taken 4 centimeters, but they have asked the question for 1 centimeter. So don't get confused by that. So that is one question, and one very similar question had also been asked in the NEET exam. Let me just open that. Yeah. Yeah. So I will try to take questions from all these exams. So some days it will be from NEET, some days it will be from CT, some days from JEE, and I will try to keep the levels of questions varying. But today we covered, like, it was an introductory class, so first class essentially on the topic. So we have covered less things and we know less concepts. So based on this, whatever this is an easy level of problem essentially, and it is very similar to the problem that we just solved. But as we go ahead and as we add to the concepts that we are learning, I will try to increase the difficulty of questions and then try to solve it here. Some questions I will solve here, and I might also give you some problems for homework. If I do give some problems for homework, I will also provide the solutions so that you can tally whatever you have solved. Okay, so we'll solve this one problem and then we will stop. इसमें ये क्वेश्चन में गिवन इन्फॉर्मेशन क्या दिया हुआ है कि एक स्प्रिंग इज स्ट्रेच्ड by 5 centimeters. So displacement has been given 5 centimeter, which is equal to meters. Yeah, by a force of 10 Newton. The time period of oscillation when the mass of 2 kgs is suspended by it is. So what has been asked is the time period. उन्होंने क्या बोला है, एक स्प्रिंग दिया हुआ है, उसका डिस्प्लेसमेंट 5 सेंटीमीटर है, फोर्स 10 न्यूटन है, मास जो अटैच्ड है वो स्प्रिंग को, दैट इज 2 kg मास. Then what is the time period of oscillation in this case? So it is a very, essentially the same problem, but they had asked this so easy problem in NEET of 2021. So you'll also find these kinds of quick and less conceptual problems in the exam. So keep looking out for these kinds of problems and don't miss out marks on these problems. That is essentially what I wanted to say. And they have asked time period. सो अगेन टाइम पीरियड का जो फॉर्मूला हमने निकाला था 2 पाई अपॉन ओमेगा इज इक्वल टू 2 पाई अपॉन रूट के बाई एम इज इक्वल टू 2 पाई अपॉन 2 पाई के अपॉन एम कर, ठीक है। ये जो हमने रीअरेंज कर लिया फॉर इजी कैलकुलेशन, फॉर क्विक कैलकुलेशन, एंड देन दिस इज जस्ट m का वैल्यू दिया है 2 kg. Now we don't have k. I forgot the step of we still don't know k. So we can find out k by again using f is equal to minus kx, right? So k ka again, we just want a magnitude of k. So we can just write this as f upon x, right? f दिया हुआ है यहाँ पे और x दिया हुआ है. So f is 10 Newton, x is 5 centimeter. This is just 2 into 10 to the power 2 न्यूटन पर मीटर, ठीक है। ये आ गया हमारा k. तो ये k को हम यहाँ पे सब्स्टिट्यूट करेंगे. And this will just be 2 pi upon, this will happen, and 1 upon 100 ka root is just 10. And this is because now see, we can't keep the pi as it is because they have given answers in like numbers. So you have to convert it into fractions. And this is just and the time will be seconds में, ठीक है. So this is our answer final, and we can see that it is 0.628, and options में correct option is this. So our answer is 0.628, and I have also put the correct answer from the source of this question, and so that is the correct answer. So that is how you can very easily solve these kinds of questions. There is like another this thing also, but we did not cover this part today. This is based on uh, the portion of after we solve the differential equation and we find the the equation for velocity and displacement. So I will keep this for next time. Okay. And yeah, so I mean I'm done, but I can take more, but then I'll not complete the thing that I will start.
No
So
problem, madam. You
yeah,
can stop as per your convenience. I am there. I will close the class. Once
yeah,
you say I'm done.
yeah. I think we can stop.
Okay.
Yeah,
So, student friends, see, this is wonderful class. Physics is really interesting if you take the interest in physics and related mathematics. So, what is related mathematics? It's basically derivatives, sometimes integration, sometimes basic mathematics. As madam told you rightly, and as I explained you initially, that she is from the background where she knows MHCET pattern, she knows basically JEE mains pattern, she knows ICER aptitude test pattern. This is going to be really helpful to you. Class was wonderful as far as I am and my expectation is concerned. Your expectation you can always send me by feedback, which you are so poor that you never send feedback. You never attend classes. 250 students are there, 255. We expect you to save money of your parents by not going to coaching classes, but we expect you to go to coaching classes. No problem at all. You attend your college school, but you also attend these classes which are so useful that some really stalwarts, experts are telling you how to go about it. Like madam has gone with so many concepts in the velocity displacement. Once I interfered her with the differential equation and derivatives. She tried to explain you something. Then she really proceeded with some mathematical calculations. Now, many of you may be poor in mathematical calculations, but your queries need to, madam, your mic is on.
yeah. Sorry. Yeah,
So your queries need to come to me. I will send it to madam. Then madam will explain you at the next class. See, we do not have any hurry. We expect of 2026 students should be present here. 2025 good students like Aryan is present. Sometimes Safir is present from Odisha. They are attending only because they are sincere, dedicated, and they respect me and my mission of providing free education. Now, madam is supporting that. So, why don't you understand that your presence and your attendance with sincerity is much more important to crack GE or CET or any of the competitive exam which she has cracked? And we have one stalwart here. So, I hope next time onwards you will take the benefit of this opportunity. Madam has closed early because in between I interfered and she could not cover some concept actual theoretically, so she could not enter into the problem. But next time she will be available. We wish her best of luck for next journey of astrophysics. But before that, those who are interested in visiting Shridon to see Saturn, Jupiter, Venus, and celestial objects, I have delivered 3000 plus lecture. Last lecture was about astronomy, which I delivered as a general lecture. You are most welcome, including Prajakta Madam. So we stop here. Thank you very much, Madam, for joining in. We'll be in touch with you. Bye-bye. Good night.
Yeah. Thank you.
Thank you, ma'am. Bye. Good night. Thank you, students. Good night.